Hi everyone, welcome back. This is lesson 2 in Unit 3B, and today's lesson is called Dot Diagrams of Covalent Compounds. So, in the last video, we talked about what covalent compounds were, what covalent bonds were, how they were formed, and the different properties of them. And today we're going to spend time going over how to draw the dot diagrams of them. Okay, so let's start with the rules. If we were going to look this up in a textbook would say 1. The central atom would usually be the less electronegative atom. Remember when we talked about electronegativity, that's the want for electrons, and this value can be found on table S. Rule number 2, they would say, hydrogen and group 17 elements are never central atoms. Rule number 3, make sure all atoms have a full valence outer shell. Hydrogen should have 2 electrons, everything else should have 8. So out of all of this is the most important thing. The other two bullet points, they don't make much sense as of yet. So those are the textbook rules. But my rules, or my helpful tips, would be draw the dot diagrams for the atoms first, then kind of show where they attach, and then draw the final product. So this way, the dot structure for the atoms kind of act like puzzle pieces, and you're just arranging them to where they fit. Kind of like putting together a puzzle piece. So if we look at HCl, so we have H and we have Cl. So I'm going to color code this to make it easier to follow. So remember we talked about dot diagrams and I said it's super important to do it in a specific way. It will haunt you if you don't. Well, this is why. And when we get into a different example, it's even more evident. So here we have H and we have Cl. And we know that this is a covalent compound because we have a nonmetal and a nonmetal. And so electrons are going to be shared. So instead of ionic bonds where an electron was pulled out, stolen from the metal, and given to the nonmetal, these nonmetals are going to share them. So remember, every element wants that full valence shell. Now chlorine has this empty spot over here. Hydrogen has an empty spot. So they look at each other and like, if hydrogen says, chlorine, if I share that last electron with you, your lonely electron with you, and I share my lonely electron, then neither of our electrons are lonely and we're good. So what happens, and what you guys can do, is either, draw an arrow to show where it belongs, or literally just circle those 2 electrons. So now that pair is going to be shared. And so when you draw that, this is where the puzzle piece comes into play. So you can move this dot somewhere, but H and that dot move as one unit. So H, let's just put its dot over there, is going to attach to chlorine right there. These are chlorine's dots. And there, that's your dot structure. That's it. So let me get a different color. This right there is that one shared pair of electrons. So hydrogen sharing its lonely electron, chlorine sharing its lonely electron. Now neither electron are lonely, they are bonded together. So if we wanted to redraw this, to kind of simplify this a bit, you can. So whenever you have 2 dots that are shared, 2 electrons or one pair, we can show that with one line, just like that. With chlorine, now if we're talking about dot structures, you do kind of need your dots. So then you'll just add your lonely unshared electrons from HCl. So either one of those, totally fine. When we talk about bond and molecular polarity, having those extra electrons makes that topic so much easier. So that's basically it. Matching those lonely electrons and then kind of putting them together. Okay, so let's look at water. Here we have H, here we have another H, here we have O, and again, this is super important to draw your dots the right way. So water should look like a little Mickey Mouse compound. And so that's kind of just a fact. If you're drawing water and it doesn't look like Mickey Mouse, you did something wrong. So if you drew your dots around and then around again, like I was doing when I was talking, that will give you the Mickey Mouse shape. So again, oxygen has 2 lonely electrons. Hydrogen each has 1 lonely electron. So what you're going to want to do is pair up those lonely electrons. So, let me get a different color. If you pair these two together, and then you pair those two together, now everybody has what they need. So if we're going to redraw this, let's draw oxygen, which looks like this. And so that green H will attach itself on the right side, and that red H will attach itself on the bottom. So here, that's a perfect dot diagram of water. Again, you see that bent or that Mickey Mouse shape. And again, here are those shared electrons. So if you wanted to simplify this, what you could do is draw H, and instead of drawing these two dots, just draw a line with that O. Same thing with this line O, the H, and then the not the lonely, but the unpaired lone electrons. So this would be a perfect dot diagram for water as well. Again, it's just matching up empty places and kind of sticking it together. Now, if we look at it, remember every element wants to have a full valence shell. So oxygen now has 8 valent electrons. It's happy. Hydrogen, remember, can only hold 2, so that hydrogen's happy, and the other hydrogen is happy. So that's kind of a good way to check. So let's do one more. This one's a bit challenging, but I believe in you all. We can do this. I am here to help you. Okay, so if you draw this, we have H, like that. You have C, which looks like this. And you have N, which looks like that. Okay, so again, we want to match our lonely electrons with the lonely electron on another compound. So let's match H's electron with that. So that's one pair that we've made. Now, carbon still has 3 lonely electrons. Nitrogen still has 3 lonely electrons. So, and it gets a little bit messy here, but bear with me. That matches together. Those match together. And those pair together. So now, when you do this, you can kind of see, if you turn your head sideways, that there's one shared pair or one connection between H and C, and there are 3 connections between N and C. So if we're going to draw this a little bit neater, we have H right there, and you have C, so that represents part of it. And then C has those other 3 electrons, and nitrogen has those, like that, with nitrogen's extra lonely pair. So this would be a dot diagram for this. But normally you don't see the 6 dots like that. What you'll see is this. So remember, one shared pair is a single bond, so that's one line, just like that. Now if we have 3 pairs, that's a triple bond, and we can even see that here with the 3 connections. And you draw it like that with nitrogen's lonely electrons. So there is your perfect dot diagram. So either one of these would work. This one's a little bit neater, less dots, easier to read. Both are accurate. So just let's go back to the helpful tip page. So another helpful tip is that the number of lonely electrons equals the number of bonds or lines it can make. So what I mean by that, if you look at carbon carbon has 4 lonely electrons, so it can make up to 4 bonds. So 4 lines should be coming off of carbon at all times. Now, if you look at, let's say, nitrogen, nitrogen has 3 lonely electrons, so that's 3 bonds it can make. If we look at oxygen, oxygen has, I'm just getting really messy. Oxygen has two lonely electrons, so it can make 2 bonds. So it should have 2 lines coming off of it. And if you look at H has 1 lonely electron, so it can only make 1 bond. So the number of lonely electrons equals the number of bonds it can make, so the number of lines it should have coming off of it. Again, you see that here, 1 lonely electron for H, 1 line connecting them. Oxygen has 2 empty spots. It can make, oxygen itself has 2 lines coming off of it, but H can only have 1 line. And same thing with here. So it's literally just looking at it like a puzzle piece. Drawing the atoms and then connecting the lonely electrons really is the best way to go about doing this. So that is it for this video. We will spend multiple days practicing before we move on. So if you're a little bit confused, don't worry yet. It is not the time to panic. It is never time to freak out and panic. Anyway, next video, we'll talk about how to name molecular or covalent compounds, same thing. And so that's pretty much it.